Patty Simpson with Simpson Math. In this video, we're going to look at some vocabulary that we use when we are talking about medical tests. So we all go into the doctor at some point throughout our lives and have a medical test run. So maybe we go in and they look for the flu, or they swab us for strep throat, or as a woman I go in and have a mammogram done. And we get back test results that say you're positive for the disease or you're negative for the disease. Well, sometimes those results are actually wrong. We may get a positive result back and it turns out we don't have the disease, or we may get a negative result back and it turns out we did have the disease. So when we are talking about those tests and those results, we use certain words to help us with that. So the first word we're going to look at is this word prevalence. And the word prevalence just means how often does the disease show up in the population. So the prevalence is the percentage of the population that is affected with a particular disease at a particular time. So for instance, here, the prevalence of a disease is 1%. How many people have the disease? Well, it depends on the size of our population. 1% of the population is expected to have that disease. So if I have 100 people, 1% of 100 is just 1. That's what 1% means. It means 1 out of 100. So 1 out of every 100 people would be expected to have that disease. If my population is larger, let's say that my population is 1,000. Notice I multiplied my denominator by 10. I just multiplied my numerator by 10. Because 1% of 1,000 is just 10. I would expect 10 people to have the disease out of 1,000 people. And if I had 10,000 people, well then I would expect 100 people to have the disease. So I just take my population and multiply it by 1% to find out how many people in that population should have the disease. So that's what the word prevalence means, is how many people out of your population should be affected by this disease. Then we have the sensitivity. The sensitivity of the test just tells of the people who have the disease, what percentage of those will the test show they actually have the disease. We call that the true positive. So in medical diagnosis, it's the ability of the test to correctly identify those with a disease, the true positive rate. So again, for instance, if we have a test that has a sensitivity of 90%, how many people with the disease test positive? Well, if 100 people come in with the disease, what that means is that 90% of the time, the test is going to show that they have the disease. They're going to walk out with a positive test. So 90 out of the 100 people with the disease walk out with a positive test. Now, if my population is larger, let's say I have 1,000 people with the disease, well then 900 of them walk out with the test, with a positive test. If 10,000 of my people have the disease, then I would expect 9,000 of them to walk out with a positive test, positive result. Notice though that some of the people who have the disease walk off with a negative test. 10 of them may walk out and their test said negative even though they have the disease. That is called a false negative. They have the disease, but the result says negative. They got a false negative. Here, the specificity is the ability of the test to show a true negative. In other words, if I walk in and I do not have the disease and they swab me, what's the rate of those who actually get a negative back? If I don't have the disease, I should get a negative. Well, in medical diagnosis, the specificity is the ability of the test to correctly identify those without the disease. We call that the true negative. So here, the test specificity is 80%. How many people without the disease test negative? So I walk in, I don't have the disease. If there are 100 people who walk in without the disease, 80 of them we expect to walk out with a negative test. Now that means that 20 of them are walking out with a positive test. That positive test is called a false positive. It's not a real positive because they don't have the disease. So that's how specificity, sensitivity, and prevalence works. So those are our true negative, our true positive, and this is just how often it shows up in our population. Also know that there is a false positive, so I could get a positive even though I don't have the disease, and I could get a negative, a false negative, where I get a negative when really I do have the disease. We're going to use this vocabulary as we build two-way tables and we look at Bayes' theorem here in the future. Math Made Simple at Simpson Math. Thanks for watching.